In this video, I introduce DINO, self-distillation with no label. Vision transformer uses encoder-only transformer to learn visual representations from input images. An extra token class is pretended to the input tokens, and its output generated by transformer is used as input to a multiple layer perceptron head to classify the input image. The self-tension of the token class on the last layer of a transformer is instance segmentation, which is learned by self-supervised learning. The input image is partitioned as patches that are linearly projected to input tokens, which are combined with positional information, and then the sum of embeddings are used as inputs to the VIT encoder, as shown here. It's the architecture of a vision transformer, and this transformer encoder. This is the input image, and this is the patches. We first use a linear projection to embedding the input patches, and then we sum the positional information to get the final embeddings to input to the transformer encoder. This is the special token class. Its output, namely self-attention, is instant segmentation. And this output can be used as an input to MLP head to predict the class of the input image. DINO is a form of self-distillation with no labels based on VIT, which passes one pair of views, X1 and X2, to the student and teacher networks, as shown here. This X1, and this X2. The student network is trained by stochastic gradient descent via back propagation for a self-target P2, as shown here. This is a teacher network, and this is a student network. While the teacher network is updated by exponential moving average, namely, we use the teacher model parameters theta t and the student model parameters theta s together to update the teacher network. The output P2 of the teacher network needs to be centered with the mean over the batch, as shown here, where C is calculated from the mean and C. Each network outputs a k-dimensional feature vectors that is normalized with the temperature softmax over the feature dimension. Their similarities are measured with a cross entropy loss here. Knowledge distillation uses a teacher network G theta t to train a student network G theta s, given an input image as X. Both networks output probability distributions PS and PT over k dimensions. The probabilities PS and PT are computed by using noise contractive estimation, as shown here, where tau is a temperature parameter that controls the sharpness of the output distribution. Given a fixed teacher network G theta t, DINO trains the student network G set S to match G set T by minimizing the crossing traffic loss with respect to the parameters set S as shown here. Given an image, distortion and crop operations on the full input image are used to produce different views. For example, two global views, X1G and X2G. That is larger than 50% of the input image, and several local views that are smaller than 50% of input image. DINO minimizes the loss to train the student network, as shown here. For more details, please check with these references. Thank you. Bye.